So we're looking at Unit 6, Lesson 7, the sine law. So now we're going to look into problems where our triangle is no longer 90 degrees. So here I have a triangle that has an 80-degree angle, a 55-degree angle, and a 45-degree angle. Now you can see all three angles add up to 180 degrees. But what we have done previously was to use the ratios, the sine, cosine, and tangent ratios, to solve right angle triangles, and we cannot use those here because they only work for 90-degree triangles. Now, it turns out there is a formula that will help us solve an acute triangle such as this one. Now, there is a relationship between the ratios of the sine of an angle over its opposite side length. And the ratio of the sine of an angle and its opposite side length is equal to the ratio of another angle in the triangle, the sine of that angle divided by the length of its opposite side, and that's also equal to the sine of the third angle to the length of its opposite side. And that formula is what we call the sine law. So if I were to write this out, I would say if you look at angle A, angle B, angle C, and I write out their the labels for the lengths of the sides of my triangle. Well, opposite to angle A would be lowercase a, opposite to angle C would be lowercase c, and opposite to angle B would be lowercase b. And so A, B, and C, all these lowercase a, B, and C are the lengths of my triangle. Now, let's write out the sine law. So the sine law states that I have the length of my side divided by the length of the divided by the sine of the angle A. So this is the ratio between the sine of angle A and the length of its opposite side. Okay, that ratio is equal to the length of side B divided by the sine of the angle B. So that's side B, and the length that's length B divided by the sine of the angle. It's 55 degrees. And that's also equal to the ratio between the length of C divided by the sine of angle C. And you can also flip the formula around, and you could also say the sine of angle A divided by the length A equals the sine of angle B divided by the length B, and that's equal to the sine of angle C over the length C. So you can just flip the top and the bottom around, and it still works because these are just ratios. Now, the formula that you want to use depends on what you're looking for. So if I'm looking for a side length, it's much easier to use the version of the sine law that, this is called the sine law, by the way. So use the version of the sine law that has the lengths at the top. Okay. I'm calling the sine law, don't confuse it with sine ratio, SOHCAHTOA. That's just the ratio. The sine law is a law, it's a formula that we use to help us solve acute triangles. Now, you might see, okay, why are there two equal signs? These are just all equivalent ratios. When you're solving a triangle, you only ever use two ratios at any given time. So now if I'm looking for the length of AC, so A to C is let's just erase these highlights for a moment. A to C would be this length here, okay, and that we said was the length lowercase b. So I'm going to find lowercase b. So if I'm looking for lowercase b, I'm going to use that ratio that contains lowercase b. So b over sine b. I have angle B. I'm looking for lowercase b, the side length. Now I'm going to make that equal to another ratio on my triangle, and that ratio is what I'm given. So I'm given the side length A, and I'm also given angle A. So I can use the ratio for A over sine A. So A over sine A. So I'm going to use this part of my sine law, equating the two ratios. Okay. Now the proof for why the sine law works, why is this formula a formula that we can use, that's not going to be explored in this video. I may post another video that proves the sine law, but for now we're just going to use the sine law. Okay, so if I apply the sine law, it says here that b divided by the sine of 55 degrees is equal to a, which is 12 meters, divided by the sine of angle A, so the sine of 80 degrees. And so I have an equation with only one unknown, and so you see if I had used c over sine c, I would run into a problem because I don't know c, but I know 45 degrees, but I just don't know the length c. So you'd end up having two unknowns in your equation. But because I used a, and I know angle A and I know side A, I'm left with only just one unknown in my equation, which is just b. So I have this equation where I equate the two ratios, and I have to solve for b. Okay, so solving for b, what do I have to do? Multiply both sides by sine 55 because the goal is to isolate b. So multiply by sine 55, those cancel on the left, and so on the left I'm left with b equals 12 sine 55 over sine of 80 degrees. And if I evaluate that, I need a calculator. Let me see if I can evaluate it here. So if we evaluate, nope, it won't give me the answer. So I need a calculator. So you must make sure your calculator is in degree mode before you do this. And so I evaluate first the sine 12 times sine 55. And then I divide by sine of 80. And that gives you a b value. Oops. Okay, let me show it to you on the Windows calculator instead of so I can't show you anything on my hand calculator. So calculator, okay. So 12 times sine of 55 degrees. And I'm going to divide that by the sine of 80 degrees. And the answer I get is 9.98, which I'll just round to 10. So b equals 10 meters. And that's my side length. Okay, so let's look at another example. So example 2, determine the measure of angle S. So here I have to draw my triangle DST. So let's draw a triangle. Let's call that D. This over here is S, and let's call that side corner T. Angle D is 47 degrees. Lowercase d is 78. So opposite of angle D, I have to write my lowercase d. And so that's going to be 78 centimeters. Okay, S is 106. So opposite of angle S is going to be lowercase s, which is 106. And opposite of angle T is lowercase t, but I don't know what that one is. So my sine law, it doesn't matter we don't have A, B, and C. All you're doing is expressing the ratio of the sine of your angle divided by the opposite side length. So if I have angle D, so I'll say sine of angle D divided by the length of its opposite side D. That's equal to the ratio between the other sets of letters. So I can make it equal to the ratio of sine T over its opposite side length T. And that's also equal to the ratio of sine of angle S divided by the side length of its opposite side lowercase s, right? And to solve this, if I'm looking for angle S, then I'm going to use the part of my sine law that has angle S, which is this part here. And then I'm going to equate that to another ratio in my sine law that I have the values for. So I have the values for angle D and side D, so I'm going to use that one there. Now I don't know anything about angle T or lowercase t, so I cannot use that part. So what I will say here is the sine of, so I'm looking for sine of angle S, so the sine of angle S divided by the length of its opposite side, 106, is equal to the sine of angle D, which is 47, divided by the length of its opposite side, 78. So if I solve for angle S, I would say sine of s, multiply both sides by 106. So I have 106 times sine of 47 degrees divided by 78. So take my calculator. Now remember, uh, we're not. This is so I'm going to do 106 times the sine of 47 degrees and divide that by 78. So I get a decimal 0.9938. Okay, so sine of s equals approximately 0.9938. But if I want angle s, I have to take the inverse. Remember, if you're looking for angles, you take the inverse. So s is the inverse sine of 0.9938. So if I took the inverse sine of that answer, I get 83.6 degrees, which I'll round to 84 degrees. So s is approximately equal to 84 degrees. All right, let's solve an application problem using the sine law. So the roof of a new house must be built to exact specifications so that the solar panels can be installed. The long rafters of the front of the house must be inclined at an angle of 26 degrees to the horizontal beam. The short rafters at the back of the house must be inclined at an angle of 66 degrees. The house is 15.3 meters wide. Determine the length of the long rafters. So even if you didn't quite understand what rafters are, what are beams, at least the diagram is given to you. So here's your triangle. You can see the triangle is this, highlighting it here. And what you're looking for is the length of the long rafters, which we could maybe label X right there. Okay. We were given two angles, 26 and 66. And I can find the third angle by using the 180-degree rule. And the third angle would be 180 minus 66 minus 26. And if I evaluate that, 88, I would get 88 degrees. So 88 goes into my diagram. Now, if I'm looking for x, I can use the sine law. So x, now the triangle has no letters, but you really don't need it. You could say the length x divided by the sine of its the opposite angle. So the angle for x is 66 degrees because the opposite of my angle is x. So sine of 66 degrees equals, so I pick another ratio that I know. I can use the 88 degrees and its opposite side length 15.3. So I can put the length on top because x is a length, which is on top. So 15.3 meters goes on top, divided by the sine of its opposite angle, which is 88 degrees. And so there's the sine law applied to this problem. 26 degrees doesn't mean anything to me here right now with the sine law because I don't have the length of its opposite side. I don't have the length of the short rafters. So this part of the sine law is all I need. X is my only unknown variable, and that's what I'm going to solve. Now all I have to do is multiply both sides by sine of 66. So I get 15.3 times sine of 66 divided by the sine of 88 degrees. And using my calculator, so 15.3 times the angle again is 66, so sine of 66 degrees, and then divided by the sine of 88, which gives me 13.98, which I will round to 14 meters. So x is approximately equal to 14 meters. So the length of the long rafters in my house is 14 meters. Okay, and that's it for my examples for the sine law, and that ends this video.